Hello, today we are doing exam 3, page 8, question 8, part A. For this, we have a conical cup. So the shape of a conical cup, it's like a triangle almost. Okay, and we are given that it is 6 meters across, 6 centimeters across, and then 9 centimeters deep. So 9 centimeters. So we are the water leaks out at the bottom at a rate of 3 um, centimeters cubic per second, and we are asked to find how fast is the water level dropping when the height of the water is 3 cm. So when it talks about the water leaking out of the bottom at a rate of 3 centimeter cubic per second, we know that this is the given of the dV over dt. dV is representing the volume, the change in volume. As you can see, it's decreasing. So it's going to be -3. So now we want so the function to find how fast the height of the height of the water is dropping, we're going to use the volume of the cup to determine this. So the volume of the conical cup is 1/3 pi r to the third power. So we want to find out. So since we're looking for the height, we're going to have a ratio of the height and put in the volume equation. So we do this by finding a ratio. So ratio, it could be r over h equals, the denominator is 6 centimeters, so 6 divided by 2 equals 3, and this is going to be our radius, because this is the diameter, and a diameter divided by 2 is always going to equal r. So r over h equals, we're going to put 3 over 9. And since we're solving for h, we're going to have r equals 1 over 3 h. And we could put this as and we could put this inside of the function. So this is actually going to be 2 times h. I apologize for that. My apologies for that. But we're gonna plug in h for the radius. So r is going to be 1 over 3 parentheses squared times h. Oh, and I'm sorry, h is actually going to be inside of the parentheses. So we're going to have this formula. So the volume is going to equal 1 over 3 pi 1 over 9 h squared times h. This is going to give us v equals 1 over 27 pi h cube. Since we have the formula now, we're going to derive this function. So as we're deriving it, we're going to get dv over dt equals 1 over 27 times pi times, and these are constants, so they're not going to change because of the h3. It's going to be 3h squared, and we're going to multiply this by dv dh over dt. And people forget to do the dh over dt. Remember what we're always looking for? or find the change in the water level. So that's going to be our change in height. So we know the values for the dv over dt. It's given in the equation in the question. So now that we have the dv over dt, we plug that in. So we plug in 1 over 27 times pi times 3 parentheses 3, because the h is going to be when the height of the water is 3 centimeters, 3 squared times dh over dt. So we're going to focus on the right side for now. So we know that when 3 multiplies the 1 over 27, this is actually going to be 1 over 9 pi times 3 squared dh over dt. 3 to the power of 2 is going to be 9, so that cancels out. So you get pi dh over dt equals -3. And to get it by itself, you just divide both sides by pi. And then you get -3 over pi equals dh over dt. Thank you. And then always to remember to put a statement for these kind of questions if your class requires it. So how I do it is I kind of start with when I use the question a lot to guide me. When the water is 3 centimeters in height, 3 cm in height, we get the change is 3 in height, the change of the height. When the water is 3 centimeters in height, the change of the water level is dropping at a rate of -3 pi. So this is saying that when the water is exactly 3 centimeters in height, the change of the water level is dropping at a rate of -3 over pi. So that's how you do, this is, I believe this is called optimization. No, not optimization, what is it called? It's, these are called related rates. Thank you for watching and have a nice day.